Hey everybody, it's Mike. Welcome back to the shop. Today we've got my son's 2002 Silverado 2500 HD with the Duramax engine. He has just over 300,000 miles on it now, and he's developed a rear pinion seal leak. So it was due for differential fluid changes anyway. So we're going to go ahead and change the fluids, but also I want to show you how to properly replace the pinion seal on the rear end of one of these AAM 11.5 rear axles, the American Axle Manufacturing 11.5. There's a lot of information out there, people doing these where they're, in my opinion, kind of not exactly doing it the way you're going to get the best life out of that rear end, so in the bearings. So I'm going to take you through and show you how I change pinion seals. I've also got another video previously where I did a Shelby GT500 Mustang late model that the guy before the shop before me had changed the pinion seal and done it incorrectly. They did not apply the correct amount of preload to the pinion, and within a few hundred miles the bearings started howling and making all kinds of noise. So if you get a chance, go back and check out that video and it'll take you through probably a little more in depth. This is going to be kind of a high-level overview of how to change this seal, and I'm going to be using the actual OEM seal, and I'll put a link to the seal part number from AAM in the description. So now we pulled the tires and wheels. I put a pry bar in, and I compressed the calipers just a little bit to reduce the friction so that I can check and get a good baseline on the rotating torque of the pinion without the weight of the tires, without the extra friction and drag of the brakes. So just to give me a good baseline. There's no specifications on this other than the pinion itself, preload. So this is what you're looking for, is a baseline of your system, and then you're going to want to go back to that plus a couple pounds, inch pounds, for make sure you have the proper preload on it. Anyway, let's like I said, I already got the tires and wheels off. I've already got the fluid drained. Can't remember if we've got the son was pulling the drive shaft, so we'll get to that. Okay, so I've got this set up here just for a quick demonstration. You get your ring gear, your pinion gear obviously feeds into it. So here's the misconception of the crush sleeve. And I just grabbed a couple of examples here out of my drawer. This one I believe is out of a 488, and this one's out of a AAM 11.5. So I didn't have one for the Dana 44, but this is just for comparison's sake. So you have on your pinion, you have your inner bearing, which is generally an interference fit. I've clearanced this particular one because this is a setup bearing. So ordinarily that needs to be pressed on, or better yet, heated up and dropped on. Generally the outer pinion, or sometimes they call it the front pinion, but the outer pinion is generally also an interference fit, but it's usually within a thou. It goes on not too, the bottom ones are usually 2 to 3, the other ones are usually a thou, so they're, or right on, so you have to really get them just perfect to get them on. Now, the misconception is the crush sleeve sets your preload. That is not exactly accurate. The crush sleeve is part of the preload equation, if you will, but you can also get solid spacers and shims, which on high performance applications, that's actually, I don't use the crush sleeves. I generally use the solid spacer and shim it to get the preload. Preload is not determined by the crush sleeve. Preload is determined by the opposing conical bearings, because you have your races that are in the axle housing that are set at a predetermined distance, or a predetermined dimension, if you will. They're pressed in there. The bearings, as you tighten the yoke and the nut, it pushes these bearings together. Mainly this one here is going to be fixed. This one out here will go down, and it will go, again, this is an exaggeration, because the crush sleeve should sit right here. Both the crush sleeves I have available on hand are wrong size, so let's just do that then. So it sits like that. This bearing comes down. Technically, the crush sleeve should ride on the inner race of the bearing. It doesn't touch the cage, it sits on the inner race. So as that bearing is tightened, The preload is the dimension as these bearings go to tighten together. That's where you get your resistance from. Most new bearings are in the 18 to 25 range. This is generic. You want to check for your specific application. Used bearings are usually a little less, usually in the 5 to 8, 5 to 10 range. But when that's pressing together, that's where your preload is coming from. You are just acting upon the crush sleeve, and the crush sleeve is opposing that force. So think of the crush sleeve as it will mate with the inner race on the outer bearing and create that resistance as you're trying to tighten it. That does one of two things. Number one, it puts pressure on this inner race so that it doesn't spin on the pinion, but also think of it as a lock nut, if you will, because if you didn't have the spacer in here, you could still tighten the yoke down, tighten your nut down. You could still achieve your proper preload even without a crush sleeve. You would just be tightening it against these bearings on their conical races. The problem with that is that's a possibility that as these loosened up a little bit, that could spin that inner race and it could back that nut off. So the crush sleeve is in place to create that compression force that holds that inner race as well as holds everything together, so that that's where you get your preload or your resistance to the bearing spinning. So I hope that kind of makes sense. The crush sleeve is an integral part of the preload equation, but it is not what sets your preload. The preload is determined by these bearings seating into their conical races in the housing. So, like I say, this is just for demonstration purposes, but we want to, I want to kind of clarify that. I see a lot of erroneous information that your crush sleeve is your preload. Now, that being said also, when you tighten this down, you want to sneak up on that rotating torque. When you measure this with an inch-pound torque wrench, you don't want to measure your breakaway torque, which is what initially you'll see the needle move to. You want to go what it settles down to as you're rotating it through an arc. That's your rotating torque. Now, if you tighten this down too far, so say you're shooting for 20 inch-pounds of rotating torque and you get a little overzealous on the torque wrench or on the breaker bar, and you crush that too much, meaning you crush this crush sleeve too much, you put these bearings into their cones too deep, and you say you see 30 inch-pounds of rotating torque and you want to back that off a little bit, that is where you need to replace the crush sleeve. If you're going down and tightening it, theoretically they say you should replace this every time. If you go past your torque specs and you crush this too far, yes, this needs to be replaced. You do not want to back that off, because now you have the option, or that bearing has the ability to, once it comes loose now, to sit in there and float. And it may be on a very, very minute level, but that bearing can sit in there and float. You're going to develop excessive wear, and you're going to impose probably a vibration or some kind of a frequency-driven harmonic that will get in there. If you want to see another video, recently I did a Shelby GT Mustang where the guy did just that. He changed the pinion seal, put it all back together, did not put he tightened it up to where it was before, which was not the proper amount of preload, and within a few hundred miles, that rear end was singing, making all kinds of noise. When I pulled it apart, you could see the excessive wear from the bearings onto the races. That car only had 57,000 miles, and it looked like it had 257,000 on those races. That was because the person who changed the seal did not put the proper preload on these bearings. So just keep that in mind. Another thing while we're right here is, please don't rattle these on with an impact gun. I've used an impact gun to kind of zip the nut down and pull the yoke on a little bit, but once you get to the point where that bearing is making contact with the race, switch over to a ratchet or breaker bar or something, hold it with a grunt tool, or better yet, a torque multiplier, but you do not want to hammer those on. You're hammering those bearings into the races,
and you're creating stress risers that are basically the beginning of the end for that bearing. Will it fail in 100 miles, 1,000 miles, 10,000? It's hard to say, but the brittling is going to start beginning when those rollers start cyclically impacting that race. So please don't use an impact hammer he's on. I know there's a lot of videos I've seen where guys will mark it and then just hammer the nut on until they get to that mark. Just because you haven't had problems doesn't necessarily mean that's the right way to do it. There's something to be said about a lot of luck involved in some of these. So just please make sure that you tighten these properly and give that bearing the best possible chance for survival. So let's go back and check the rotating torque on what we've got here.
All right, so you want to establish a baseline before you pull this apart. Now, just to keep the numbers relatively low as far as the inch-pound, I've pulled the tires and wheels off, and then I've also pushed the calipers, compressed the calipers a little bit so they are not dragging as much on the rotors. There again, if you go back and look at that Shelby GT video I did here not too long ago, I did the same thing on that when I was trying to establish a baseline. There is no spec on this. There's only specs on the pinion themselves, but that's without turning a carrier, axle shafts, everything else. So this is not a spec per se, so don't follow my advice to the exact spec. What you're looking for is to see what this baseline is before you pull all this apart. So let's see what we're sitting at. And then again, you don't want to look at breakaway, you want to look at what it settles to. And that is about 25, 26 inch-pounds, 25 inch-pounds of rotating torque. And that's spinning the pinion, carrier, and the axle shafts, 25. I'd like to do it at least three times and take the average. So I'm gonna say 25 inch-pounds. So make a note of that. So when you put this back together, I like to go at least the 25, generally I like to add a couple. So I'm gonna shoot for probably 27, 28 inch-pounds of rotating torque on that. So if we was to disassemble this whole axle, my guess would be, and I don't like to guess, but I've done enough of these to know that with everything, turning everything in here, I would say on these used bearings, you're probably gonna be somewhere in the 5 to 7 inch-pounds of rotating torque on this used bearing. So if we were to put it back together and test it again with my theory, or with my method here, we'd probably see a 6 to 8, 6 to 9. So still well within the range of a used bearing, but we just want to go down to where that crush sleeve is and maybe just compress a little bit more. If you don't go to at least this setting, you may be putting the preload on, but you're not getting that opposing resistance from the crush sleeve. So eventually when this yoke starts coming loose because it doesn't have the tension from that crush sleeve on there holding it, that's where you'd start seeing problems. So that is where I generally see the biggest misinformation out there, is people will rattle them on and go to the same point on the nut. Well, if you replace the nut, you're supposed to replace the nut. It's a locking nut. So if you replace the nut, how are you supposed to go back to that same point? You can mark them, you can transfer the marks over, whatever, but all that is really a gray area. I much prefer to check it with an inch-pound torque wrench and look at the data. The specification or the baseline says this. Now, when I go back together, I'm gonna put it back to that. And just for argument's sake, I'm gonna back this nut off a little bit, tap on it a couple times to simulate some miles, and then we're gonna check it, and I will show you what the inch-pound So back the nut off a little bit. I've relaxed the yoke on the pinion and just took a reading, and it is about 19, it's the needle's width under 20. So it's dropped about roughly 6 inch-pounds of rotating torque. So that's pretty much what the pinion preload would have been, because you're still turning the carrier and you have the carrier bearings out here that are adding preload, plus the bearings out in your hubs. So basically I just proved that you're looking at about 5 to 8. So this is probably 5-ish, 6 on these used bearings. So that's where we'll put it back. We'll put it back to
the 25 or probably 27, 28 range, and that way we will know we've met and slightly exceeded our baseline when it goes back together. Another thing is we're doing a fluid change anyway, but I've seen people pull these apart and you end up losing so much fluid out the front. You might as well just incorporate a fluid change into the whole project because you're going to end up with a mess everywhere. You might as well just drain your fluid first. So when you pull this apart, you have a little residual where the bearing rides. But then also, if you notice right here, there's a channel that goes from here back. That channel is the drain from this outer pinion. I like to inspect that and make sure there's no debris, make sure. Now we pulled the magnet out of this. The magnet was good, so there wasn't excessive, but I just like to make sure this drain from the outer bearing back is clean, because if that backs up there, that can also back up fluid up against the seal, which is can be a little aid to an early demise. But also you need to make sure that fluid is moving around that. As that ring gear's turning, it's slinging oil up in here, and you want to make sure it has a clean, clear return path. So when we get this apart, I'll show you where the port is, but you can see it cast in the outside of the housing here. Similar scenario to not beating the yolks on. You really don't want to beat them off either. And there again, I see a lot of that happening on Instagram and YouTube, I guess, more particular. But you're going to do the same thing. You're going to cause damage to those bearings. So get a puller, pull it off, and again, give those bearings the best chance for a long, happy life. They've got a rough life as it is. You want to prolong their life as best you can. So there's the yoke. Just what you knock in there. And there we go. And the yoke and balancer are off. At this point, we went ahead, before we pulled the seal, we went ahead and cleaned the bulk of the buildup and stuff on the housing, on the differential. So when we pull the seal, we'll have a little bit of remnants here. But yeah, it was caked on there pretty good. So we scraped it off with just a wide blade screwdriver and then chased it with a brush and some brake wash, got it all cleaned off. So we're gonna go ahead now and remove the seal. And there's no easy way to do this. So you just kind of start, work your way around. You wanna make sure you get under the lip of the seal so you don't actually deform the casting there. So, or the new one won't seat properly. So I like to bend that flange up out of the way a little bit and then give it a couple of pretty good smacks. And what that actually does is it kind of compresses the seal just a little bit. Then, if you haven't fabricated yourself one of these, go ahead and do so. It's just a pair of vice grips, and then I machined a threaded bung on the end. So you can grab hold, thread your favorite slide bar or slide hammer in. A couple of smacks and the seal is out. Easy peasy. Takes less than a minute. So like I said, if you haven't made one of those attachments for your slide hammer, do yourself a favor. That comes in very handy on a multitude of items. So now that that's out, I'm going to go ahead and pull the, got a dirtier rag, wipe that out.
Now I can feel the drain back, so I'm going to see if I'm going to move the camera here and see if I can get it to show up on camera. But it is right there. You can see right under the outermost part of the rollers. You can see the drain back. You just kind of want to give that a good inspection. Make sure it's clear of any sludge or any buildup. This is spotless, so as the fluid comes up through, that's your drain back. So we're looking good there. So now we can go ahead and focus on putting the new seal back in. So this is what you get in the kit if you get this from American Axle Manufacturer. And I will leave the part number is 74020013. I'll leave a part number in the description also. But you get the seal, you get the new Speedy sleeve that goes on the factory yoke. GM actually used this from the factory. Most of your other ones do not have this. So if you check your yoke carefully, if you do have a groove where the seal rides, you're going to want to install a Speedy sleeve on it. And we'll go ahead and put this on the yoke here. There's the new seal. It also comes with a new crush sleeve, nut, and washer, which we will use. We have not pulled the bearing apart, so I can achieve the compression with what's in there. So we'll go ahead and put this. Now, one other thing I like to do is I like to pack the back side of these seals just a little bit with grease or some kind of petroleum jelly, so that as you're tapping it in, it keeps the seal, the little spring on the back side, it keeps that from bouncing out, that you don't realize until well after the fact. So, and that grease is soluble, so it'll just dissolve and run right back down into the lube. So when you drive these in, I've seen people hammer them side to side to side to side, and that ends up just kind of cocking them and walking them in there. It works, but I prefer to use a seal installer or some kind of a driver that will span evenly and press evenly, the seal evenly into the bore. Now also on a lot of these, I will take a very thin layer of RTV, like the GM ES is my sealant of preference. I will run a very thin bead around. This AAM axle, factory one, actually has rubber around it here, so it does not require sealant. You can put some on if you want, but I'm going to choose not to. I'm just going to go ahead and put it in dry. But again, I'm just going to use a seal installer. This fits over the pinion, and we'll drive that in. So let's go back into the vehicle and get this seal in place. Then we'll replace the wear ring on the yoke. Back into the vehicle here. Going to go through and just make sure you go one final wipe on that inner bore. Make sure everything's cleaned off good.
No burrs.
No burrs. Set the seal in place. Evenly drive the seal in. Seal's installed. So let's go back over to the bench. Oh, and there's also a little bit of grease, or I use Seal Glide, but on the inside where the yoke will ride. GM actually, or AAM actually, in correspondence with GM, use a Speedy sleeve or a wear sleeve, if you will, from the factory. So here's the new one that comes with it. On some of the Dodges that I've run across, and a lot of other vehicles for that matter, that don't, if you notice wear in there, that's when you'll want to install a Speedy sleeve, and then when you put your new seal in. Otherwise, there's not enough pre-tension on the seal, and it will more than likely leak again. This one looks like it's more, I can scrape it off with my fingernail. There's no actual wear there. It looks like it's actually just the rubber transfer onto the hardened inner sleeve. But
to show how these are replaced, I'm going to go ahead and do it anyway. Now, this one's a little different because it actually has a rubber seal in the outside edge here built into it. Most of them are just the sleeve part. And what you'll want to do is take a chisel and run it parallel with the shaft, or perpendicular to the seal, if you will. And it's best to use a chisel that spans the whole width of the seal, or the wear sleeve. If not, you have to make multiple taps. But what you're doing is, as you're hitting that, you're dislodging or moving the metal, and it's actually expanding it. So sometimes 2-3 times, or 2-3 different locations around the ring will be adequate. But you'll just take and hit it in a couple of spots, and it expands it. And then get on the back side, and just a few light taps, and usually they will come right off. On the speedy sleeves, I've actually got underneath the back side with like a heel bar and a couple of heel bars, and kind of walked them right off once you get them expanded a little bit. Now these ones are a little different because they're actually rubber encapsulated, or they have a rubber on the inside as well, so it's not as tight of an interference fit. Actually, I'm going to use the heel bars. It's not as tight of an interference fit as some of them. So you just take and go ahead and go in there and boom, walks it right off. I know a lot of people are not changing these. If there's no wear or no issues with it, you probably don't have to, but you've paid for it. If you bought the full install kit, you paid for it, you might as well use it. And again, I also wanted to just kind of show how to go about changing it. They're pretty easy to change, so I'm not quite sure why people are not changing them. This is definitely, if you look at them, this outer ring is hard as a rock and broken in pieces, so it's probably a good thing we're changing it. To drive it on, you can take a socket or some kind of a driver that fits as tight to the inside diameter of that as possible. And I like to press them on with the press. I don't like to beat them on, but you can hammer them on. So before I do that, I'm going to actually clean some of this sealant off where it's going to be going back together. And also inside the splines, there is a sealant from the factory that they put on these. So I just took a general purpose wire brush and just kind of went in there. Now, as I go to put this on the outside edge here, I will go ahead at about, I don't know, 1/2 inch deep maybe. I will put RTV, I use GM ES engine sealant, and I'll smear that around there. So as this is going on over the splines, that last little bit, it will actually seal. Then when you put the washer, because so a little bit will build up there, then when you put the washer on, it seals the splines using that RTV and on the back side, because you can actually, I've actually seen where a leak can exist where the oil has migrated up the splines and started coming out. So I always, on every rear end I always put a little bit of RTV, a little bit of sealant on the last little bit of thread, so as that's going on, you're sealing that off. Then when you put the washer on, you can actually also put a little bit on the back side of the washer. It would do the same thing. However you want to do it. I generally just put the last, like I said, the last 3/8, 1/2 inch of the spline, so as it's going on, it's actually pushing it, and then when you put the washer on, it creates that seal. So we're over here at the press. We're going to go ahead and put sleeve in place and press this down.
and that's ready to go over and be installed. So the seal's installed. I got the new wear ring on the yoke. Finding my pin mark. I got a pin mark on the shaft here so I can get it timed right, going back on. I put a little bit of gray sealant on the splines. Pin mark, point to it here. Pin mark right there. Pin mark right there. Slide that on. Lightly tap it. Get it seated. I'm going to go ahead and use the old nut here to draw it on. The washer in place. And that grunt tool. Tighten this on now. I'm watching the back side here and watching the gap close up, and I'll be able to feel when it bottoms out. Okay, at that point I'm going to go ahead and run this nut off and put the new nut going on. Has Loctite on it. Go ahead and start it. Go ahead and lock that grunt tool up against the leaf springs. Okay, now I'm going to go ahead and torque check the rotating torque. So we haven't gotten there yet. I don't think I'll be able to put enough on it with just the ratchet here anyway, so. So we're not even back to our baseline yet. Make this easier on me here. Switch over to the torque multiplier so I can sneak up on it. Okay. $24-ish. All right, I think we're there. That's right at 30. Trying to get consistent. Yep, we're gonna leave it right there. So we have gone to the baseline plus about 4. Yeah, plus about 4. We're right at the 2930 range. So that's where we're going to leave it. Last thing I like to do on mine is put cross check on it, paint mark it. So at that point, we're ready to stab the drive shaft back in, and this job's done. Put fluid in it and this job's done. All right, so there we go. Put the drive shaft back in. All put back together there. Differential cover, all fluid back in it. So that job's done. So hopefully that was informative and cleared up some of the mysteries on changing one of these and really doing it right so you don't run the risk of damaging your bearings or not getting enough preload on those bearings and ended up having a bearing failure. So anyway, I hope this was helpful. Let me know what you think. Appreciate it. Thanks for watching.